This is section 4.5, derivatives of trigonometric functions. We're going to learn how to take derivatives of trigonometric functions, but first we're going to review the basics of trigonometry. So this is if you're, somewhat unfamiliar with the trig functions, etc. Consider a right triangle, which means that this angle right here is 90 degrees, right? We draw a little box to signify that. And suppose we're interested in this angle, which we're frequently going to call theta. We're going to consider the side opposite of theta, the side adjacent to theta, and then the hypotenuse of the triangle. Okay, now just some basic trig derivatives. Sine of theta, by definition, is opposite over hypotenuse, the length of that opposite side divided by the length of the hypotenuse. Cosine of theta equals the length of the adjacent side to the angle over the length of the hypotenuse of that triangle. And then tangent of theta equals length of the opposite side over the length of the adjacent side, which you also might notice is equal to sine of theta over cosine of theta. That's a good identity to remember. Now there are also the inverse definitions, so to speak. Maybe I shouldn't say inverse. The 1/overs, right? Cosecant of theta equals hypotenuse over opposite, which you might notice is 1 over sine of theta. Secant of theta equals hypotenuse over the adjacent side, which you might notice is 1 over cosine of theta. And then cotangent of theta equals adjacent, like the length of the adjacent side, over the length of the opposite side. And you might notice that that's 1 over tangent of theta. And you also might notice that that's cosine of theta over sine of theta. These are all good identities to know. Now, these three are far and away the most important, but these guys are also important, so you need to know them. Okay? Now, you may be familiar with your unit circle, and we're just going to give a little refresher as to how we derive that sort of thing. So suppose we have a set of axes right here. This is the x-axis, the y-axis, right? And we have a circle, right? Suppose we have, right? I shouldn't even say it. Forget about the circle. Suppose we have a triangle. Suppose we have this right triangle. Go down right here, okay? And right. Now, the cool thing about trigonometry and about these functions, sine, cosine, etc., is it turns out it doesn't actually matter how big or small your triangle is, right? If we had a triangle that were this big, like that, sine, cosine, tangent of theta would still be the same thing, okay? So these work for any size triangle. So because of that, we're going to make our triangle the nicest possible triangle. And so when we consider this angle theta, we're going to make the hypotenuse 1, right? Because sine and cosine divide by the hypotenuse. Why not make that hypotenuse 1? So in this situation, for this triangle, the length of this side, let me just make that angle sign a little bit nicer. There we go. Hypotenuse is 1, then if this is the opposite side, and this is the adjacent side, and the hypotenuse equals 1, then you might notice that the length of the opposite side actually equals sine of theta, right? Because it's the opposite side over 1. It's the hypotenuse. And similarly, the adjacent side is cosine of theta, right? Because again, we're dividing by 1, right? Oh, there you go. Now, this was an arbitrary triangle. I could have created this guy as well, right? Maybe that guy, right? With, also with hypotenuse length 1, right? Considered that right triangle. Considered this angle. If they had done the same thing, right? And in fact, I could have done this, right? And because of the Pythagorean theorem, right, we know that the sides of the triangle are all related, and so really we could just come up with this unit circle. Well, that not even over, right? But pretend this is a circle. Yeah, there we go. Unit circle. Pretend that those touch perfectly. Okay, so we have the unit circle. Maybe I'll even move this a little bit, right? Center that. Something like that. Maybe expand it a little bit. Something like that, okay? And we know, again, based on the Pythagorean theorem, that because the radius of our unit circle is always 1, that, I got the highlighter out here, a squared plus b squared equals c squared. And so that means that sine squared of theta plus cosine squared of theta equals 1. Actually, I guess I should do this the other way. I think this was cosine, this was sine, and then this is... Okay. And so this is where we get possibly the most fundamental trigonometric identity. And it's just... actually, let me see if I can... And it's just an implication of the Pythagorean theorem. There we go. Okay, so that's definitely something we need to know. Now, there are various things about the unit circle. Just the last thing I'll do before I end this video is just some basic values. For theta, this is what sine of theta is. This is what cosine of theta is. When we're talking about radians, by the way, we don't measure theta in terms of degrees. Just remember that the circumference of this unit circle is 2 pi, which is the same as 60 degrees. So we remember the fundamental identity that 360 degrees equals 2 pi. Okay? So if we're interested in radians, like what's the radians for 30 degrees? We'll just divide 360 by 12 to get 30 degrees and divide 2 pi by 12. I get the same thing. So anyway, when you do that, the most interesting angles are 0, pi over 6, which is 30 degrees, pi over 4, which is 45 degrees, pi over 3, which is 60 degrees, and then pi over 2, which is 90 degrees. Okay? And it turns out that sine of 0 is 0, cosine of 0 is 1. That's just, again, looking at the situation. What is the length of this so-called triangle? Okay, it's that. If you know your 30-60 triangles with the hypotenuse of 1, you know sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. If you know your 45-90 triangles, you know this is true. You know what, let me actually draw this diagonally because it's a little, for space reasons. For 60 degrees, we get this, and then for 90 degrees, we get that. Okay? And then it's the same thing for angles in these quadrants. It's just a matter of whether they're positive or negative. So you might remember this little mnemonic over here. All students take calculus. But that's all for the trig review.